Good morning, teacher. My name is Dylan Elvis Alfaro. This class is the workshop number 8. The course is the vehicle engineering. The first step is activate manage employee system. First, click on plugin manager and select yes, add-ons track, and finally clicking OK. Then to create a full vehicle assembly, first select in the menu, select the option file, open and assembly, and search a truck chariot and select assembly.tbl and double click on MSC tractor semi-trailer.easy and finally select OK. Then verify system units, click on settings, then click on units, check status, MMKS system units, and finally click on OK. Then simulate full vehicle system. First click on simulate, then click full vehicle analysis and select single line change from the open loop steering events option. Finally select single line change. Change the data. In the box, write test 1 in output prefix, write 10 in end time, write 100 in number of steps, initial velocity 16, maximum steer value 16, start time is 1 and steering input 2, and finally clicking OK. Animating analysis results. Frontal review menu, select animator controls and select the play tool, advanced car animates the maneuver. Plotting the analysis results. Launch Adam Post processor. Verify that source is set to request is the number 2. Number 3, from the simulation list, select test 1. And finally, select option as show as follows. Plotting test 1. In the following plotting results is the sign that the last plotting we see how it affects the deflection of the tires of a trailer. On this case, we have two lines, trailer and the trailer. It's similar to the plotting results of the rear. In this case, we also see how the deflection affects and how it returns to its normal state once the abrupt maneuver of change or direction finishes. Simulate test 2 is the similar steps with test 1. First click on simulate, then click full vehicle analysis, then select single line change, then change the data. In this case, I change the initial velocity for 15 km/h. And about the plotting results, plotting test 2. About the plotting results of test 2, in this case we use a lower initial speed at 15 km/h. And if we look at the axis and the deformation, it has its least speed. Since in the plotting result of test 1 it had a speed of 16 km/h and the formation can have about 25.5 millimeters. In this case it is smaller, only reaching 21.5 millimeters. The questions. Question number 1. How forces on tires affect chassis system? The resistance to rolling is a force that affects the pneumatic. It is practically the forces that impede the movement and also depends on the chassis, because if it has more weight, there will be more friction and the vehicle will move slower. Also depends of the coefficient of friction of the material that is made tire and that of the surface. Question number 2. What tire is speed rating? The speed rating of a tire indicates the optimum speed that a tire can maintain safely over time. In short, it is the fastest speed a tire can handle before it stops working. As designate this speed rating system is designed to help control the safe performance of tires on standard speeds. On this case, the letter B indicated the velocity who the tires can go in. In this picture, B is 214 km per hour. Question number 3, does nitrogen make a difference in tires? As a general rule, the inflation with nitrogen is always a good option because to preserve the life of the tires, since in addition to the advantage already mentioned, it has many more benefits. Keeps tire pressure for longer and more stable. They are not affected by high temperatures or sudden change. Improve the behavior of the tires. It favors the saving of fuel. It emits less CO2. Care more about the environment. It is compatible with any tire.